question number 9, we have to prove that angle AOB is 90 degrees. So I just started with taking these two triangles OPA and triangle OCA, and I'm trying to prove these congruent. Now these triangles can be proved congruent using multiple ways. Like I'm using the one I used to prove that the length of tangents from the external point are equal. So I'm using RHS rule here. You could also use SSS, because right now you are aware that the tangents drawn from external point are equal. So PA will be equal to PC. Then this is your common side, and this being the radius will be equal. So you can also do this by SSS. I have taken the perpendicular at point of contact over here. So I'll be using RHS rule and the triangles will be congruent. And once the triangles are congruent, triangle OAP is congruent to triangle OAC by RHS rule. I'm going to write down the equality of angles over here. So angle this and this, these will be equal. I'm writing by name here. Angle POA will be equal to angle COA. This will be by CPCT. And let each of these equal to X. Now this is very simple. We have just done the congruence. How does this help us will be making sense in a while. Similarly, I can prove the congruence of the triangles on the other side. I'll just highlight those angles. Triangle OQB and triangle OCB. I'm going to write down that we can prove the congruence of these two triangles similarly. So triangle OQB will be congruent to triangle OCB. Similarly, exactly on the same lines, you can either prove the congruence of these two triangles by SSS, or you can prove the congruence of these triangles by RHS. Once these triangles are congruent, I'm going to take the angles marked here equal to each other by CPCT and let them equal to Y. And then you can write down angle COB will be equal to angle QOB. This will be equal by CPCT, and I'm going to take them as Y each. Anyone with any questions still here?
No, ma'am.
Then there's just one thing we want to do.
No, ma'am.
We are going to use the result that POQ is a straight line. POQ, the diameter is a straight line, and the angle formed on a straight line or a straight angle is 180 degrees. तो ये जो angles मैंने mark किए हैं x x y y, इन चारों का sum कितना हो जाएगा 180 degrees. That's the next thing I want to use. And I hope you can conclude your result by now, that you will be getting the sum of x and y as 180 degrees, 90 degrees, which implies, now over here you want to just write down the angles which make AOB equal to 180 degrees. The sum of x and y is 90. So I would like to do this in such a way. I'm going to take the ones which will form my angle, this one and this one. So AOC and COB. Replace x and y by these two. X will be replaced by AOB and y will be replaced by BOC. Sorry, AOC and COB. And you can replace it right here where you've obtained that x plus y is 180, and eventually you will get the required result. So x is angle AOC plus Y is angle COB. The sum of these two is 90, and these two combined actually form angle AOB, and hence is your result. Anyone with any questions? If you're writing
No,
now,
ma'am.
please let me
No,
know.
No, ma'am.
no, ma'am.
Question number 10. Prove that the angle between the two tangents, this is the angle between the tangents from an external point of the circle. The angle between the tangents is supplementary to the angle subtended by the line segments that join the point of contact to the center. So if there is a circle and you have drawn tangents from an external point, the angle between these two, let's mark this as number 1. And then we want to take the second angle by joining point of contact to the center. So point of contacts ये बन रहे हैं, इनको center से join कर दो, इनके बीच में जो angle बन रहा है, these two. You want to prove angle 1 and angle 2 is supplementary, 180 degrees. This is the result that I had mentioned after theorem 10.2 as a note, and I discussed the proof for this as well. Rhythm, can you answer how will we prove angle 1 plus angle 2 equals to 180 degrees?
No, ma'am.
Anyone else? If P is the external point and O is the center of the circle, A and B are the points of contact. By using the theorems that you already have, theorem 10.1, at point of contact we get 90-degree angles. And this is forming a quadrilateral. So we have quadrilateral PAOB. We are going to use angle sum property. The sum of the four angles of a quadrilateral is, that's correct, Kanishka. We will be using angle sum property. So once you apply the angle sum property in this triangle, angle 3 and angle 4 are 90-degree because tangents are perpendicular at point of contact. So you will get 1 plus 2 equals to 180 degrees. Let's write the answer for this. I'm going to number the angles which I want to prove. I've been given a
Excuse me, ma'am.
circle. Yes.
मैम आपने दोनों जगह P लिखा है.
Actually, this should be circle with center O and PA and PB are tangents. You can either write down that angle APB and angle AOB. The sum of these two is 180 degrees, or simply writing down angle 1 plus angle 2 is equal to 180 degrees. So this is theorem 10.1, the first theorem. We will have angle PAO equals to 90 degrees and angle PBO equals to 90 degrees. Afterwards, we will use angle sum property in quadrilateral. Anyone with any questions here?
Never, ma'am.
Anyone who's writing down?
Yes, ma'am.
No, ma'am.
Done, ma'am.
Let's take up the next question. I think we've done question number 11. Yes, question number 11 we have done, where you want to prove that the parallelogram which circumscribes a circle is a rhombus. So question number 11th is similar to question number 8. You can remember. Question number 12 we'll do at the end. I'm taking up question number 13th right now. Question number 13th will have the same figure as question number 8th and 11th. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Let's just take a look at how the figure would be, and then we will write down its answer. So this is what we have. There is a quadrilateral ABCD which is circumscribing a circle with center O. The result that you want to prove is कि अगर हम opposite sides के end points को center से connect करते हैं, means we want to find out the angles subtended by opposite sides at the center. So let's take the pair of sides AB and CD. The angle subtended by AB at the center वो बनेगा by joining A with center and joining B with the center. So this over here is the angle subtended by AB at the center. Similarly, अगर देखना है कि CD कौन सा एंगल बनाएगी सेंटर पे, तो join the end points to the center, and this is the second angle. This is angle COD, angle subtended by the opposite side. You have to prove that these are supplementary, means their sum is 180 degrees. Similarly, the other pair from this side and from this side, these two will also be supplementary. This is what we want to prove. I hope the question is clear. Anyone with any questions? What is given to be proved? Prove क्या करना है? This is very important to understand.
No, ma'am.
And please be careful, don't consider AC a straight line. The way I have drawn, it might seem कि हम ये diagonals हैं तो ये vertically opposite angles बनेंगे, हम वो कुछ use कर सकते हैं. No, that's not the case here. It's not always necessary that AC will be passing through the center O. So don't consider AC a straight line. So right now we have to prove that angle AOB and COD are supplementary, angle BOC and angle AOD are supplementary. Let's write down quadrilateral ABCD. So we are going to do some construction here. I would like to join center to all the points of contact that I can see here. So there are 4 points of contact. I'm going to join the center with all of them. Let's join O with S, O with R, O with Q, and O with P. I'm going to start by taking 2 triangles. Let's start from these two. triangle AOS and triangle AOP. I'm going to prove the congruence of these two. Similarly, I can take the triangles from the other point, other vertex of the quadrilateral, like these two. बट हम बार बार नहीं करेंगे, हम एक पेयर की कॉन्ग्रुएंस के बाद बाकी सभी पेयर्स के लिए सिमिलरली वर्ड यूज करेंगे. लेट्स राइट डाउन. In triangle AOS and triangle AOP, AO is equal to AO, this is the common side. OS is equal to OP and AS is equal to AP. By side rule, triangle AOS is congruent to triangle AOP. And from here, I'm going to conclude a result for the angles marked at the center. This one and this one. I'm going to take these two as x each. So this implies that angle AOS will be equal to angle AOP by CPCT, and I'm going to take these as x each. Now I'm going to use similarly for the other pairs of triangles. Triangle BOP will be congruent to triangle BOQ, and I will have the angles at the center equal. Angle BOP will be equal to angle BOQ by CPCT, and I'm going to take them as y each. So this angle can be taken as y and this angle can be taken as y. Take the third pair, triangle COQ is congruent to triangle COR, and from here take these central angles equal by CPCT. And you can use a different variable, let's take them as Z each. So this angle will be Z and this angle will be Z. Let's take the fourth pair of triangles. Triangle DOR will be congruent to triangle DOS. Angles at the center will be equal by CPCT. Let's take them as W each. You can take numbers also अगर आपको convenient लगता है numbers mark करने. So this angle will be W and this angle will also be W. Anyone with questions still here? The last
No,
question,
ma'am.
the last question that we did, वहाँ पे जब मैंने x x और y y mark किए थे, I used the result that they are forming a straight angle. Right now, the angles that I have marked as x, y, z, w in pairs. What do you think the property I'll use in this case? These are all angles around a point, around the center of the circle. What would be the sum of all these?
360.
That's correct. angle at a point is 360 degrees. The sum of all these angles will be 360. And now you want to replace the angles in such a way that you get your required result. Take the names x and y together and z and w together. So identify the central angles represented by x, y, z and o by their actual names. And take them in such a way that once you take them together, you get the result that you require. So x and y actually form, from the figure you can identify angle AOP and BOP. So that these two together make AOB. And for Z and W, I'm going to the opposite side. I'm going to take, I've taken this one and this one, I'll go other side and I'll take these two, COR and DOR. And these two form angle AOB plus these two form angle COD. This sum is 180 degrees. And you can write down similarly, the sum of other two angles will be equal to 180 degrees. Anyone with any questions?
No, ma'am.
Anyone who's writing down, should I wait?
Yes, ma'am.
I'll wait.
Yes, ma'am. Done, ma'am.
Kavan was writing. Kavan, have you done beta?
Done, ma'am.
Question number 12. It's an application based question now. A triangle ABC is drawn here, which is circumscribing a circle. As you can see, the sides are tangents to the circle. One of the point of contact is marked as D. You can mark the others as E and F if you want. And then the side BC is tangent in such a way that the parts of side BC are divided in two segments. One of them is 6 and one of them is 8. That means the total length of this side will be 14 centimeters. You have to find out the lengths of sides AB and AC. You have the length of one side. You have to find out the length of the other side. The circle given here has a radius 4 centimeters. So the length of OD will be 4 centimeters. This is what you have. Using this, we will be finding the lengths of these sides. Quickly, I'll just let you know कि हमने क्या क्या यहाँ पे use करना है, so that when I write down, it makes sense to you. The first thing we will be using is that we've got tangents from external point. तीनों vertices से A से B से C से, but they are tangents from external point. They'll be equal in length. तो अगर हम बात करते हैं from point A, I've got tangents AE and AF. They will be equal in length. These two will be equal, AF and AE. Similarly, the tangents from B will be equal in length. Now, this particular tangent from B to D is 8 centimeters. So that means this will be 8 centimeters. The tangents from C will be equal. So this segment will be equal to this one, and hence this will be 6 centimeters. And I could take the representation for these for convenience, that the tangents from A are also equal. Let them each equal to x. This is the first thing we are using, that the tangents drawn from external point to a circle are equal in length, with the help of which I will get the lengths of these two tangents, and I have taken the ones drawn from A as x each. Afterwards, we are going to use the concept that area of parts of a figure is equal to the area of the whole figure. अब इसको divide इस तरह से करना है that you get triangles in which you have perpendiculars. I'm going to join the center with all the three vertices. So you will be able to see three triangles. आपके पास एक बेस पे ट्राइंगल बन रहा है, ट्राइंगल BOC, and there is one triangle from side AB, AOB, and AOC. I can just number the triangle so that it's easier to identify. This is number one, and this is number two, and this is number three. These are the three triangles. We will be using that area of triangle one plus area of triangle two plus area of triangle three is equal to area of triangle ABC. जो ये पार्ट्स हैं, इनका एरिया हम निकालेंगे हाफ बेस हाइट से, और जो होल ट्राइंगल है इसका एरिया हम लिखेंगे with the help of Heron's formula. And then you will be able to find out x. Once you have x, you can find out the lengths of the triangles. Majorly, this is what we are going to use. The area of the three parts is equal to the area of the whole triangle. Parts का एरिया हमने हाफ बेस हाइट से निकालना है, और होल ट्राइंगल का एरिया हमने हेरॉन्स की हेल्प से निकालना है. Let's write down. this is what we're going to use, and I'm going to work out all of these and then use it in equation number 1. You can find these values one by one and then put these in the equation here. So let's find out, first of all, area of triangle AOB. This can be written as half base into height. The base will be the side of the triangle and height will be the radius of the circle. If you want, you can mark this in the diagram that these are the perpendiculars we will be using as heights of the triangle. So for triangle AOB, the side is AB. Let me write that so that it's convenient. AB and the perpendicular is OE. So using that, you can just put the values here, x plus 8, and the height is actually the radius of the circle. So radius is 4 centimeters. From here, you can evaluate. This will be 2 into x plus 8 centimeters square. Then you have area of triangle BOC. This will be again half base into height. The base of the triangle will be BC and this will be OD. Okay, Sahaj beta, you have questions from that?
Yes, ma'am.
I'll give you a day when we will discuss that.
Okay, ma'am. Thank you.
Thank you, Kanishka. I'll get a warning here. I'm not using the one which gets shut down. Thank you so much. This is what we have for the third triangle on the left hand side. Now I'm going to find out the area of the whole triangle. Now for the whole triangle, I have to use Heron's formula, so that this might take a little longer than the way it did for the parts of the triangle. Now for area of triangle ABC, I'm going to use Heron. So first thing I want to do is I want to find out the semi-perimeter. So semi-perimeter will be given by sum of all sides divided by 2. The sides are x plus 8, x plus 6, and 14. This complete sum divided by 2. From the numerator, I get 2x plus 28 over 2. Please don't cancel 2 directly. Take 2 common and then cancel. So the semi-perimeter comes out to be x plus 14. Now I can apply Heron's formula. Area of triangle ABC under the root semi-perimeter, then S minus the first side. अगर नहीं याद तो आप लिख सकते हो, ये रिजल्ट यूज कर रहे हैं हम. And take your time to solve this bracket, although it's very simple, but still be careful with the signs. And those who want to skip these steps, they can do it in their mind directly and write down the answer. Cancelling terms, x gets cancelled in this bracket, in this bracket, in the last bracket 14 gets cancelled. So we get square root x plus 14 into 6 into 8 into x. So this is 48x into x plus 14 under the root centimeter square. Use the values of the areas we have obtained in equation number 1. But if the meeting ends, I would like to restart. I would like to complete this question. It's less than a minute. Let's use the areas. We've got twice x plus 8 plus 28 plus twice x plus 6 equals to square root of 48x plus x plus 14. On the left hand side, on simplification, you get 4x plus 56 equals to square root of 48x into x plus 14. Let's deal with this square root, square both sides.